Welcome to Lesson 18 in the C# from Start to Finish course. My name is Tim Corey, and today we're going to finally finish the Create Tournament form. This is going to be a logic-heavy lesson. We're going to move a lot of parts around to accomplish our goal. That means it's a very easy place for me to lose you. Maybe you're already feeling a bit anxious after the last lesson, where we didn't really test things and we left a couple of things undone. I've said this before, but I'll say it again. Relax. Don't panic. We'll get through this. This might seem overwhelming, and that's okay. You might not understand it the first time. That's okay too. Take your time and do it along with me. Rewatch the video a couple times. Don't rush through this and hope that everything will work out okay. And definitely don't just watch this and think that by watching, somehow you're going to get it. It takes practice. It takes work. And in my case particularly, it takes some visualization. Sometimes my students forget that I'm a real person. They think that somehow these applications come out of my brain fully formed. And that just isn't so. In fact, I've tried hard throughout this course to show you my mistakes. I didn't contrive my mistakes to make a teaching moment. I'm showing you how I actually build an application. That means that in my design, sometimes I get it wrong. Sometimes my code isn't that well thought through. And sometimes I've had to rework a few things. Hopefully that gives you hope. Development is always going to have its struggles. Today will be one of those days where we struggle to visualize what we're going to do, since there's so many moving pieces. I'm going to start us off by visualizing what I am envisioning for our application. This diagram represents what my notebook looks like after designing this lesson. And before I explain it all, let me say that even now, good design starts on paper. If you don't know exactly how you're going to do something, design it first on paper, because that makes it much easier to redo. In fact, I've redone this particular section 3 times since our last lesson. I had a couple concerns with the logic, so I tried 3 different ways to accomplish the goal before arriving at this solution. I know I'm repeating what I tell you before, but I really hope you take it to heart. This is important to learn, to design first on paper. All right, so enough lecturing. Let's actually look at this diagram and see what we're doing. Over here, we have the teams. Now, what I did was said, we're going to design our matchups. Remember, we did everything for saving a tournament except actually create the matchups and matchup entries. And over here on the right, I have the matchup entries and the matchups tables in their columns. So what I decided to do was create a sample of 3 teams, Jen, Tim, and Sue. Pretend these are teams. Now the 4th one's called bye, because I want to simulate the idea of not having enough teams. Remember, the first thing we need to do is fill in. So for example, if we have 7 teams, we have to add an 8th in order to have an even bracket. So in this case, I'm simulating 3 teams so that I can make sure that I know what I'm going to do with that bye. Now I said, okay, let's create our first round of matchups and see how that looks. So I create this matchup and I said, well, that's ID number 1. We'll need that ID for later. And then I said, well, Jen and Tim would be in that first matchup because they're the first 2 in the list. Remember, this will be randomized. So Jen plays Tim, and I said each one of these, this is the MEID, which is the matchup entries ID. So Jen has a matchup entry ID of 1, so that'd be the ID of 1. It'd be a parent matchup ID of 0. The team competing would be Jen's team, and the score would be, nothing right now. And then Tim is a matchup ID of 2. And so again, 2 here, 0 here, Tim's ID here for his team, and again, score of 0. The matchup number 2, again, this is matchup, so 2 would be the ID for matchups, and the round would be 1. Winner would be empty. It's nullable. And the tournament ID would already be supplied by the tournament. So matchup ID number 2, we have Sue. That'd be 3 up here, 0, Sue's team, and a 0 for score. And then bye. So what do we do with bye? Because bye doesn't really have a team ID. Well, what I said was we have a matchup entry of 0. And what this represents is the idea that we don't actually have a matchup entry for the bye entry. So we'd only have one matchup entry for this matchup. So for this matchup, we only have one team competing, because it makes no sense to have a matchup entry where the matchup entry ID, or the matchup ID, is for 0, and so on and so forth. There's no information in here that's actually relevant. We're not going to give it a score. We're not going to assign a team. And it won't have a parent because byes only happen in the first round. So therefore, we're going to leave it as no entry here. And therefore, we only have one team. Therefore, we already know who the winner is. So now, that's great for the first round because we know all the teams that will be competing in the matchup. But what about this second round of matchups? Well, really, we don't know. We can create a matchup ID for it, say 3, and we can say winner ID is obviously, we don't know yet, but we know the tournament ID. We know which round it is, round 2. But then the first matchup entry, we're actually going to create one and say, we know which entry it is. We'll give it an ID. We'll say here's the entry for this matchup. The parent matchup, we're going to know. We're going to say parent matchup for this record right here is 1, meaning over here. And the teams competing, we're not going to know. So we actually have to change this from not null to be null. So we won't know the team competing, but we'll know where it came from. And that's important because we can then link this back to its predecessor. So this matchup ID number 3, knows that it links to this matchup and this matchup. And these are the two competitors in this matchup. And so for each of the matchup entries, this one right here, the number 1, the matchup entry ID will know. We will know the parent matchup, and the score will be blank because we don't know a score yet. And the team competing will also be blank because we don't know yet who the winner is of this first round. Now, the same thing is true for this one, except that really what we'll do is we will automatically move Sue's team into this because we know she's going to win her matchup with the bye week. So it's a little bit rough. It's a little bit of a sketch idea of what we're going to do. But this kind of outlines for us the basics of how we're going to lay out our tournament. The first round we'll have populated with people, with teams. The second round, except for the bye week entries, which I ignored at this point, but for the second round and beyond, we won't know who is going to be playing, but we'll know where they're coming from, and that's good enough. That means we can capture this entire pyramid. It's really a pyramid at side. But this pyramid here, even if it's even larger, where if we had 16 teams or 32 teams or 64 teams, we could capture all the different rounds. Remember, each matchup gets a round number, so we know which round it's in. And even if we are another layer deep, we would just say, say we had a matchup down here, we would say, well, one of the records like here would point back to this matchup, and the other one would point down to this one down here that's not yet there, but we pretend it is. So we could still point back to matchups even though those matchups don't even know who's playing in them yet. So we can draw the bracket out. We can draw the pyramid out without having which team is going to play. We just know that if Tim wins, he goes on to this spot right here in matchup 3. If Jen wins, she goes on to the spot in matchup 3. And down here, we know that Sue wins, therefore she'll be over here in a second spot. Okay, so that's the idea. Let's move over to the actual code and see how it's going to play out. Before we do anything else, I want to actually modify that one table. Remember that matchup entries, we designed this. We have to change that one column, team competing ID, to allow nulls. I'm going to go ahead and save that. And I'm going to get this message: saving changes is not permitted. The change you have made requires the following table to be dropped and recreated. You have either made changes to a table that can't be recreated, or enabled the option prevent saving changes that requires a table to be recreated. So this is a setting inside SQL that says if the table needs to be recreated, which means dropped and re-added, which means basically destroyed and rebuilt, that we can't do that. We have to actually either enable this option in here, or we have to do something different. We can't make this change. So I'm actually going to enable that option. So in order to do that, what I'm going to do is hit cancel. I'll actually close this out without saving this change. I'll go to Tools and Options. Are you sure you want to do it? And that's because I have those relationships set up, and one of those is for team competing ID because it links to the team table. And that's okay. I can say, yep, I know what's going to happen. That's fine. Okay, now we're done with that change. And that's the only change to SQL that I needed to make. Let's come back over here to our code and actually start working on this change. So I double click on my tournament button, and it comes to this spot right here. And we have to actually wire up our matchups. Here's what to do. Wire up our matchups before we do the actual save of our tournament. Now, what does wire up matchups really mean? Well, let's flesh this out a little bit before we start doing any code. Let's write out in comments what we intend to do here. So the first thing you're going to do, if we look at our tournament model, we hit F12. Then down here, we have a list of matchup model. Let's look at the matchup model. Let's actually keep the tournament model open. And now hit F12 here. So in this matchup model, we have a list of matchup entries. So we have 2 entries in a matchup model. We have a winner and the round. So that's all inside of one matchup model. So you have a list of matchup models. And then inside each matchup model, we have a list of matchup entries, which are the 2 teams. So to come back over here, what we need to do is we need to, first of all, order our list randomly. And that's because we want to have that idea of it's random who gets picked when. So we don't have any bias as to when you put the team in. That's one of our way back when requirements, was that it doesn't matter which order you put the teams in, we're going to randomly pick who gets selected first, second, third. So we got to order a list randomly of teams. Next, it's really simple. For a tournament to work, you have to have 2 teams, or 2 times 2 teams, which is 4 teams, or 2 times 2 times 2 teams, which is 8 teams, or 2 times 2 times 2 teams, or 16 teams. This is called powers. 2 to the n power. This is 2 to the first. This is 2 to the second. This is 2 to the third. This is 2 to the fourth power. And you write that out, 2 caret 4. So that we're going to have to figure out which of these it fits in. And so we'll do that math in a little bit, but that won't be a big deal. It's actually pretty simple to do. And let's just take that logic or that idea and put it up here, just out of the way, and keep it in that line. So once we got enough teams, then what we need to do is create our first round of matchups. All right, we'll go through the first round because that's going to be an easy round. We'll have all the information we need. Then what we'll do is we'll create every round after that. And again, now we're dividing by 2. Because if you have 8 teams, then you'll be playing 4 matchups. And from those 4 matchups, you'll have 4 winners. Well, 8 divided by 2 is 4. Then those 4 teams will have 2 matchups. One matchup with the first 2 teams, one matchup with the second 2 teams. Out of those 2 matchups come 2 teams. 4 divided by 2 is 2. All the way down to 1. So we'll create a round for every matchup set after that. So if we have 8 matchups, let's do this. 8 matchups, then we'll have 4 matchups, then we'll have 2 matchups, and then we'll have 1 matchup. And so if our first round is this 8 matchups, then they'll be created up here, and then every round after that will be the 4 matchup round, the 2 matchup round, and the 1 matchup round. And those will be easy as well because all they're going to do is say, for this matchup, the first in this series of 4, we'll take the first 2 matchups up here, and we'll say, give me those 2 IDs, and that's now my matchup. The second matchup will say, give me the next 2 IDs. That's my matchup. All the way down through. Over here, we'll do the same thing. Grab the first 2 IDs for the first one, grab a second 2 IDs here for the second one here. And of course, this one is just the ID from each of these 2 matchups. So when you break it down, it's not that hard logically. It's just a number of pieces. So once we've done all of this, we're really done. We have all of our rounds. And if you look at the model, we just need our rounds. That's what needs to be filled in. Therefore, At this point, we can continue on with our create tournament. And there we can work on the actual saving this information to the database. So the next question is, where do we do this? Do we do this right in here? Which doesn't feel good because it feels like we're doing an awful lot of things inside the create tournament button. And we're right, it's not a great place to put it, at least not the actual logic. We'll call something because we may want to do some work after the fact. Remember that each of these matchups, matchup with a 4, with a 2, and with a 1, we don't have any people in there. There's no teams in there. The teams don't get put in there until after the first round is complete. Well, how do we put those teams in? It seems like there'll be more methods that are kind of similar to what we're doing right now. We're going to take a tournament model and kind of update it with the values once we have scores in there. So we'll probably have more work to do after the fact, after the tournament's created, once we start getting game scores in. So I like the idea of having a separate place to call this where we can reuse some of our logic. So let's come over here to our library. We want to push all the logic we can into that library. Remember that the forms aren't necessarily our final UI. We may go to a web-based or a WPF-based application at some point down the road. And so we don't want to have any logic about how the tournament works in our forms code behind, because we'll have to recreate that in the new system. So instead, we'll push it all to the library if possible. So over here in the library, we have the text connector processor, and that does some processing stuff, but it's just for text, and it doesn't really feel right there because that's part of the data access folder. And that's not what we're doing here. We're not doing data access. This is more logic. And it doesn't make sense to put it in the models folder because it's not a model. It's more doing work on a model. So let's create a new class. And we may add it to a folder at some point, but for now, we'll create it right in the root. Let's call this class Tournament Logic. Pretty straightforward. Let's make it a public static class. I don't think we're going to need to save any data long-term in this class. So instead, we'll make sure that we have our data come in and go out in the same method, and therefore can be static. Now, if we find out later, yeah, you kind of want to store information long-term, then we can convert it over. But I don't think that's in the plans right now. So let's leave it at static and see if we can start there. So what methods do we need? Well, I'm actually going to take this logic right here and copy it. And over here at the very top, before we do anything else, I'm going to paste it in. That way we know we have to do this stuff in here. So I'm actually going to create a public static void create rounds. Tournament model control dot using tracker library dot models. And this for now will be my only static, public static method. And so its job is going to be to create the rounds, or essentially do all this logic. So what will happen is over here, we can actually call it now. We can save this. Right here, we will say tournament logic dot create rounds and pass in our tournament model. So it's going to do all the work of actually creating those rounds, and it'll put them right in that tournament model variable. Because again, we don't have to pass it back and forth. We've passed it in. Now both of us have that same address, that same location. Therefore, it can do the work on it, and then we can go on to the next step, which is actually creating the tournament. So in essence, we're now done with this create tournament button underscore click. That's it. We're done. Now there's no logic here yet, so we won't actually create the rounds, but as far as this button is concerned, we're done. So let's start working on our logic. We first need to order our list of teams randomly. Well, it seems like what we need is a private static list of team model, randomize team order. And we're going to pass in a list of team model. Now, why am I passing back out a list of team if I'm passing in a list of team? Well, because we're going to pass in the list of team from this tournament model, but we won't override that list. We'll create a new list with the randomized order. So therefore, we're going to call that, and we're going to say list of team model randomized teams equals randomized teams, or team order, model dot, and where's our teams? Entered teams. There we go. So what happens here is we're going to pass in our entered teams, which is a list of team model. This method is going to randomize the order and return a new list with those randomized teams. We don't need to get super complicated. Like down here for cryptography and doing all this, that's really for if you want to be absolutely sure that it's fully randomized and all the rest, or at least as randomized as it can be. But if you keep scrolling, you have this answer. Now, there's an awful lot of discussion down here on whether this is a good idea or not, if it's a efficient way or not, and if it's actually randomized, which it's not, or not. But this is a pseudo random answer, and it's really simple. So what happens here is you take a list in, you do an order by, and that's one of those things we've done with the lambda expressions, where we say it's actually link. Instead of saying where x equals greater than sign, x dot, whatever, instead of doing that, we do order by. It's the same idea. We're going to return an ordered list, and so he uses a instead of x. But here's what we're going to order by. We're going to order by GUID.new GUID. Well, what's a GUID, first of all? A GUID is meant to be a unique identifier. In theory, there are no two GUIDs that are the same. It's going to create a very long character representation, a text representation. I believe it says down here a 16-byte value. So it's going to take a large value and create that as the ID. Well, we're going to order our entries by that new GUID for each row, which means that we have this identifier that's supposedly unique, and they don't get created in order like we do with our IDs in SQL. They're not 1, 2, 3, 4. It's just this random 16-character value. Therefore, if every row gets one of those, and we order by those, in theory, it's pretty random. And in fact, it could be fully random, or it could be not quite random, because GUIDs are not meant to be ordered. It's not designed to come out in a random order. And so we could have two that are pretty close together, or we might get a kind of clump, but in theory, they should come out randomized. Now in our instance, I'm going to copy this line. Come up with, then I can say, that randomize might not be random enough. And so I can come back here and modify just this randomized team order method because it takes in a list of team and it gives back a list of team. Everything else it doesn't care about. So I can change this method internally as much as I want. I can put that massive cryptography random system in here. And as long as I returned a list of team model, that's all it cares about. All the rest of the code will still work. So I can feel comfortable doing this now and saying later, if it doesn't work, I can come back and change it without changing half my application. All right, so how do we actually do this? Well, we're going to say return teams.order by x equals greater than GUID dot new GUID, just like they did, dot to list. Now order by sorts the elements and returns a new list. And this to list will convert to an actual list of T instead of an I ordered enumerable. So now I've returned this new list and we're good to go. Now we've just randomized our list. Excellent. It's always good to feel like you've accomplished something in your application. Even when it seems overwhelming, if you can do a small chunk or two, it really gets you in the groove of, okay, we can move on and do more. So now we've got a randomized set of teams. We next need to see if we need to have more bye weeks entered. And how are we going to do that? Well, we need to figure out which value applies to us. So let's create a new method. I'll actually create it right here. Now you may wonder how I do my ordering of my methods. And it's really pretty simple. I put my methods closest to what I'm doing, which means that this method right here gets moved down, and that's okay. What it allows me to see the work up here that I'm doing while I'm working down here, and see the work I'm doing down here while I come up here and use that. And so it keeps those two pieces of code kind of close together while I'm working on it. Then later, I will move it down again if I need another method. So it really is more a matter of efficiency while I'm coding it than it is about a specific order. Some people love to have all their public methods up top in a section and then all their private methods down below in a section, and they may even kind of rope those sections off. But I don't really find that's useful. I find it's most useful to do it as I feel it's necessary when I'm coding initially. So let's call this method private static int find number of rounds. Let's go return the number of rounds. And we're going to pass in our, let's pass in our randomized teams list, but the list of team model teams. Doesn't matter which list we pass in, but let's do that. So we're going to say int rounds equals find number of rounds. randomized teams. And so that's actually going to call it. Now we have to do the logic here. And so we're going to say, we'll do the int output equals 0. All right. Now the logic of this is a bit of a work in progress. It's something you need to work through and make sure that you run through a couple examples to make sure you got it right. When I built this, it took me about 5 or 6 passes, honestly, before I figured out exactly how the numbers work. And part of that's because I'm not great with numbers. When it comes to less than or equal to and evaluating and multiplying and all the rest, it kind of messes my brain a little bit. And so what I do, I try it. And in fact, I'll create another program and just try some examples where I'm just working through the numbers and make sure the numbers come out right. So I would encourage you to do the same. Now, the first thing I need to change here, I'm thinking about this and I say, you know what? This list of team, I don't need it. I don't need to know who the teams are. All I care about is the team count, the number of teams. So I'm going to say int team count. And then up here, I'm going to pass in just that count. Because that's all I care about is the number of teams. Now, besides my outputs, I'm also going to have this int val. I'm going to start this off at 2. I'm actually going to start my output off at 1. And that's kind of unusual for me. Usually I start an int out at 0. And what's this val all about? Well, I'm going to loop through in a in a while loop. And I'm going to try and figure out how many rounds I need to go. So let's start off by seeing it and then you kind of understand why I'm doing what I'm doing. So do a while loop. Remember, in a while loop, you evaluate what's in the parens here first to see if it's true. If it is, then you run this code inside the curly braces until it's done. Then it comes back to the top and says, is it still true? If it is, run it again. Until finally this says false, and then we skip over doing anything here and come down below, which means that a while loop could symbolizes output equals output plus 1. That's just shorthand for doing this. All right. And then we also say val times equal 2. And again, that's shorthand. And you'll probably figure this out already, but val equals val times 2. So what are we doing here? Well, we're saying that val now becomes 4 because 2 times 2 is 4. And output becomes 2. So if this is 3 and this is 4, 4 is not less than 3. Therefore, we're done. We don't do any more of running this code. Therefore, return output. Output is 2 rounds. Perfect. If the team count is 4, it's still 2 rounds. Well, 4 equals 4. Therefore, it's not less than 4. Therefore, we still return 2 rounds. You see how that works? Maybe draw it on paper and make sure that you understand how that logic is working. But essentially, what happens is we figure out by multiplying by 2. Why multiply by 2? Well, that's how the rounds work. We have to multiply by 2. So the next time it evaluates, it's going to evaluate 4 times 2 is 8. So is 8 less than the team count? The next time is 16 less than the team count. Until finally we have an evaluation that's false and we return that output. So now we know the number of rounds. But how do we know the number of buys, which is int, let's call it buys, equals what? I'm going to put 0 there for a minute. So how do we know how many buys we need? For example, if we have 3 teams, like we did in our logic design notes at the beginning of this lesson, if we have 3 teams, we have 1 buy. Well, how do we know that? Well, we need to do our multiplication here. And that's where I'll create a new method. Private static int number of buys. Int rounds. Int number of teams. Now, there is a method inside C# called math.pow. And what that does is it takes one number, let's say our number is 2, and takes it to the power of, say, 4. So if we put the number of rounds here, like this, what would happen is to say 2 to the 4th power. 2 times 2 times 2 times 2, which is 16. And that would work except for one little thing. Math.pow returns a double, and it takes in doubles as well. So we have to do a conversion back to an int. I really don't like that because it can cause a mess sometimes. Will it? Probably not. But really doing this on our own isn't that hard. So let's do that. Let's do or the number of buys. Because if we have 16 maximum teams in here, and the number of teams is 15, 16 minus 15 is 1 buy. All right? So how do we do that? Well, we're going to say for int I equals, we're going to change this up a little bit and say 1. So if I equals 1, I is less than or equal to, not the length, but instead rounds. Now it's a little bit different than we normally do with a for loop. Normally we start with I equals 0 and I is less than something. But that's for a 0-based counting system. We don't want a 0-based counting system. We want a 1-based. And here's why. Let's walk through this. We're going to count from 1 to the number of rounds. That's why it's less than or equal to. So 1, then 2, then 3, then 4, it'll run on 4, and then we're done because we won't run on 5 because 5 is not less than or equal to 4. And we're pretending like the number of rounds is 4. So what are we going to do in here? Well, we need to start total teams off at 1. And we're going to say total teams times equal 2. So if we run it once, so if number of rounds is 1, we'll come in here and say total teams times equal 2. That's why you had to have it at 1, not 0, because 0 times 2 is still 0. But 1 times 2 is 2. That's the total number of teams in a 1-round tournament. But if this is 2, we're going to go again. What's 2 times 2? That's 4. That's the total number of teams of a 2-round tournament. And so on and so forth. So that'll give us the number of teams total. After that, we can say output equals total teams minus number of teams actually in our tournament. Return output. So now we found the total number of teams, we subtracted the actual number of teams, and gotten our value of the number of buys. So now is up here, we say number of buys for rounds randomized teams dot count. So the number of rounds models, we have not a matchup entry, a matchup model. We have a list of matchup model for each round. So we'll return a list of matchup model, and we'll call this create first round. We're going to pass in int the number of buys. We're going to pass in our list of team model teams, and we'll pass in int rounds, the number of rounds we have total. Actually, we're not going to pass in the number of rounds. We don't care, because the first round, we're going to use every team plus every buy. So this first round method doesn't even need to care about the number of rounds, because it only does the first round. So we can ignore the number of rounds. Now you may ask yourself, wait a minute, you're kind of locking yourself in here because this only does a first round. Why wouldn't it do every round? Well, the first round is kind of different than all the rest, because the first round, we know who the teams are. After this first round, we don't know who the teams are. It's all based upon previous information. And so in this first round, it's different than all the rest. Therefore, it gets its own method. Now, before we actually do anything in here, let's first take a look at our matchup model to see what we need to create. It needs an ID, which we won't get yet. That gets set when we actually store it in the database. But then it needs a list of matchup entry model. So we're going to actually pop that open in just a minute. We'll close these other tabs out. We don't need them. And we'll leave this one open, and we'll actually pop open this. So it's going to create a list of these. Well, it's the team competing. We know that. Score is going to be 0. And the parent matchup, also blank. Because we don't need to know who that parent is at this point because there is no parent for this first round. So a matchup entry is pretty simple. We'll create 2 of those. We don't know the winner, and the round's going to be 1. So this first one, pretty straightforward. The only thing weird to deal with are these buys. And so how are we going to deal with those effectively? And I'll show you how I drew up this design. First, let's do a list of matchup model called output equals new list of matchup model. And then I'm going to do a for each. I'm going to say for each team model, team in teams. So it's going to loop through all of my teams here one at a time. Now, the next thing I'm going to do is I am going to create up here one matchup model. I'm going to say this is the current model equals new matchup model. And here's why. I'm going to loop through here, but remember, a team is only half of one matchup. And so what I need to do is find out what the other half is before I complete this matchup model. So I'm going to loop through. The first time I hit a team, I'm going to put that in the matchup model, but then not do anything. The next time I come through, I'm going to add the second team and then say, okay, that matchup model is complete, add it to the list and create a new one. Then loop through again, grab a third team, the fourth team, and so on and so forth. Buys will make that a little bit trickier, but essentially what will happen is I'm going to add the buys to the first teams in the list. So team number 1 gets a buy if there is one. Team number 2 gets a buy if there's 2 buys or more. And so on and so forth. That way I can get rid of those first. So let's see the logic for this. I'm going to say cur dot entries. Remember, entries is a list of matchup entry model. Dot add new entry model. And I'll say the parent matchup, we can ignore, the score we can ignore, the team competing equals team. That's the very first thing that happens. So I've added one entry. And now I'm going to say if the buys is greater than 0 or cur dot entries dot count is greater than 1. Now what does that do? Well, if we have a buy still available, meaning it's not 0, then really we're done with this current matchup because it gets a buy. We don't add another entry to our list. We just have the one. Or if we have no buys, but there's 2 entries in this list, meaning there's 2 teams. Either way, we're going to run this code where we say cur dot, we don't do ID, but we don't do winner, but we do matchup round equals 1. Why is that hard coded? Because this is create first round. Therefore, it's always 1. And then we say output dot add cur, and then we're going to say cur equals new matchup model. So we'll reuse this variable after we've added that instance to our output list. And the last thing we need to do is we need to subtract 1 from our buys if buys is greater than 0. So if buys is greater than 0, buys minus equals 1. Now what that's doing is saying if it was a buy that got us in here, then make sure you take one buy away because we've used it. Otherwise, if you had one or more buys, everyone gets a buy, and that wouldn't be a fun tournament. So now we have set the matchup round. We've added that entry. We have restarted our model, and we've subtracted one from the buy if we used one. Now we come back to the top of the for each, get the next team. We add it to cur, and we say, is buys greater than 0, or is the entry count greater than 1? Now let's pretend we only have one buy. And we already did it down here. We already did the first person, we add the buy, and complete it. So now we come back up the second time, and we add the next person, and we don't have a buy, that's 0, and the entry count is only 1, therefore it's not greater than 1. Therefore we skip over this if statement entirely, come back here, add another entry, which is a third person, and now we have 2 people in our entries list. Now entries.count is greater than 1, therefore we add that person to our list, and we create the new matchup model, which actually in a 3-person tournament wouldn't be used. But that's okay. We come back to the for each, there's no more teams, therefore we're done. Therefore we return output. And we're done. We've created our first round. Now so far, we've written an awful lot of code and haven't run this application, and that's a little scary. My encouragement to you is take pieces of this that you can test and can make sure that the logic works and put it somewhere else and make sure that it works by creating a small console application and trying it out. Because otherwise, we've now written a couple hundred lines of code that we're going to need to debug at some point. And if we have a problem, debugging a couple hundred lines is a whole lot harder than debugging 20 lines. So whenever possible, break this up into smaller chunks. The problem here is that we're really doing one flow of thought. We'd like to get through the whole flow of thought so that we actually see it work entirely. So we're not actually testing at this point yet. So that's just something to think about. If you're doing this application your own, maybe you do test it. Maybe you do try and figure out a way to get it to work temporarily. Like, for example, create rounds. Maybe at this point, you create your first round and then return everything and just look at the data and make sure it looks right. So for us now, what I'm going to do is I'm going to say model dot rounds dot add create first round buys randomized teams. And so what this does is it calls this here and then check to make sure you have one round and it's populated correctly. Because that, at this point, it runs all this code. So down here, all that code has been completed. Therefore, TM should have round 1 in it. But we're not going to stop there. We now need to do this. Create every round after that. How are we going to do that? Well, private static void create other rounds. Not a really creative name, but essentially it's every round after the first. But I just didn't want to name we don't do anymore. So up here, we will say create other rounds, model rounds, done. And again, we're not passing back a value because we're operating directly on our tournament model instance. Therefore, no passback is necessary. And if you've caught it by now, we're done with this public method. That's all it's going to do. This is a quarterback method. That's what I call it. What it does is it says, okay, you do this, you do that, you do this, and keep going on down a list, commanding others to do the job. It's kind of like the boss. It tells others what to do, and it just makes sure the flow is right from start to finish. And so in this instance, the job of create other rounds is to create every round after the first. Now, logic in here shouldn't be too tough. We're going to follow the pattern we did down here, actually, and do something very similar. It's just we're not going to have the teams to loop through. We're going to loop through the previous matchup models, or list of them. So let's start by having a int round, and this represents the current round we're on. So that'll start off at round number 2, because again, we created the first one already. So this is round 2 we're going to start on. And then let's create a list of matchup model. And we'll call this previous round. Now, what is this? Well, we have to work on the previous round in order to get the values for the current round. Therefore, we're going to capture this in a list separate from our tournament model. Because our tournament model has a number of rounds in it. We don't want to get muddled up with finding which one we want to pull out as the previous one. So we'll just create this variable here, and we'll actually populate it initially with model.rounds. We're going to say rounds number 1, which is actually position 0. So this is going to grab the first list of matchup model in our rounds variable. And since we only have one list of matchup model, and that's the one we got from here, create first round, therefore that's going to be the first round initially. So now we're going to say, while round is less than or equal to rounds. So rounds, plural, is a total number of rounds we're going to need. Round is the current round we're on. And it's less than or equal to because we have to go through that last round. Now here, the logic actually gets a little bit simpler than down here, because down here we have the current entry and the next entry and all the rest. Whereas here we're going to do a for each. For each, and it will be a matchup model. Call it match in previous round. So we're going to loop through all the matchups in this previous round. And the first time I do this, it's going to be round number 1 we're going to loop through because we're on currently round number 2. Now, what does that look like? Well, again, remember that in our example from our notes way at the beginning, we had Jen versus Tim, and we had Sue versus Bai. So those are the 2 matchups in this list. Now, Sue versus Bai be first because the first person gets the Bai. So pretend Sue versus Bai is the first matchup in here. Now, what we're going to do is we're going to have a current round. So let's do list of matchup model is current round equals new list of matchup model. And that's empty. And actually we have to add one more thing up here. We have to have a matchup model. Cur matchup equals new matchup model. So now here we can say Now, we don't have the score, and we don't have the team competing. We don't know who the winner is yet. That team competing is the winner. So we're going to create one of the parent matches. And that's it. So now we've added a new matchup entry where the parent is from the previous round, that match. If current matchup.entries.count is greater than 1. Now, just like down here, cur.entries.count is greater than 1. Same thing here. If we have more than one entry, do this. Now, why don't I say equals 2? And the reason why is because if for whatever reason I had some kind of funky logic in here where I skipped and double added something. So I added 2, or say 3 even. So I added 3 somehow. Well, if I have 3, it's not going to say equals 2. Therefore, it'll keep running and add more and more and more in an infinite loop. And that's a problem. So greater than 1 makes sure that I captured at 2, but if for whatever reason I got beyond 2, it's still okay. Now, would I really have a problem? Yeah, I'd have a problem. And that might be an instance where you say, no, I want to throw an error if it's more than 2. But in this case, I'm going to say greater than 1 for the count. So if it's greater than 1, meaning 2, then what I'm going to do is I'm going to add that to my current round. Current round dot add current matchup. And then current matchup equals new current matchup, or matchup model. So I don't have to do this by check in here, and I don't have to do this if statement down here. I just need to add the output or add to the current round and reset the actual instance. I don't have to deal with this plus equals 1 or all the rest of the stuff. Oh, I do need to deal with this equals 1 though. I need to say current matchup dot matchup round equals round. So that's the current round we're in. So it starts off at 2, then 3, 4, 5 if we get that far. So now I've added that matchup entry to my round, my current round. Then I come back to the top and keep going until I've looped through this entire previous round and created half as many matchups. Because I put 2 people in every matchup. Therefore, if I have 8 matchups in this previous round, I'll have 4 matchups entered into the current round. So that's all good. Now I get down to here. This is where we've looped through the previous round already, and we're done. Now that we're done adding the previous or the current round, now I've completed that. We need to do a little cleanup here, and we need to add this current round to our model. Model dot rounds dot add current round plus equals 1 to make sure that we are adding to this round. and we'll put it into the previous round. So now the previous round gets its value from the current round, and now I can move on to the next iteration of this loop. Once we're done all these looping, we're done. That's it. Because we've added every entry to our model.rounds so that now the model, which is tournament model, its rounds is populated with every set of rounds. And that's all we had to do in order to complete this create rounds. Before we go on, let's review our checklist of things we had to get done in this method. Order our list randomly, our list of teams. Yep, we did that. Check if it's big enough, and if not, add buys. Yep, we did that. Create our first round of matchups. Yep. And then create every round after that. Yep, we did all that. And all of that's been called inside create rounds. And create rounds was called by our code over here. I didn't have it open. All the way down here, we have that call to create the rounds. So we've wired up our matchups. Now we'll just need to make sure that we actually save our rounds inside this create tournaments method. We have that one to do yet. If you come down our task list, we'll see that we have a to-do there, capture round information, and that's in our method here, convert to tournament model. We need to capture our round information. So that's pulling the information out. We should also have a to-do down here for making sure that our setup is correct for saving the information as well. And so we'll check on that as well. That should be down here. And I bet we don't have a to-do. So we'll make sure we get that done. But that's actually going to be for the next video. And I know I really wanted to finish this in this video, but it's just too much information to do in one video without just making the video really just too long. I mean, we're almost at the blockbuster movie length. So I know this is not a blockbuster movie, but hopefully at least you do a good opening weekend. But I want to get to this logic and make sure we have it saving to the database properly and that we're pulling it back out as well. So we'll check on that in the next video and then do a whole bunch of testing and some debugging if things don't go well. So let's make sure you come back for that. Make sure we kind of finish strong on this form. And then the good news is that we are almost over this hump. And once we're over it, it's all downhill from here because the rest of the logic is really simple. And so we'll just complete out this application and then come back through. Or come back through and add exception handling or error handling. We've talked about that. We'll also add the idea of emailing people when it's their turn or to play. And we'll also even add events possibly if we need them. And we'll also add in a video that'll be just for the people who are purchasing this course. We'll have a video for not just emailing people, but also texting them. So we're going to add a few other things in here before we're actually done, but we only have 2 forms to go and then extra stuff, and then we're done with this application. So we're getting close, so stick with it, keep pushing through, and follow along as I go. So that's it for today. We'll move on to the next video shortly.